everyone, welcome to a short lesson on limits, evaluating limits. It's really important that in calculus that we understand this concept of a limit so that we can ultimately talk about calculating the slope of a tangent line to a curve. Now, what I want you to understand about substitution, when you can and when you can't, is that you definitely can when your function is nice. Like, for example, if you have a polynomial function, those guys are nice. The word we ultimately use is continuous. Your e to the x guy is nice. Sine of x and cosine of x are nice. And so forth. So what do I mean by nice? I mean that if the limit of the function coincides with the function value, your function's nice, and that's when we actually can substitute and have the limit approaching from the left, approaching from the right, be the same as the function value. So this happens anytime you have a polynomial function. If you have somebody nice like e to the x, for example, has that same property. So in the case of e to the x, the limit as x approaches a of e to the x would be e to the a. The same sort of thing holds true if you are the sine or the cosine functions. Meaning, again, if I pick a value for the input, the output and the limit of the function are the same when your function is nice. So here, for instance, you can see this nice result. So again, limit means that if you approach from the left and also from the right a value x, if the y's also approach a certain value, then that value the y's approach would be your limit. So here in this case we can say things like this. Okay, so there are certain functions that are just really great candidates for substitution. Another guy that you could look at is the polynomial guy. Look at this guy, for example. He's nice. He's a polynomial. Nice powers of x, integer powers of x, no negative exponents, nothing strange. And you can see, for example, if I pick an x value, that what I am saying with the substitution law is this: the limit of a polynomial function is indeed always the function value. So you need to make sure anytime you try to substitute that you have a valid law that goes along with this. Okay, now let me give you another example. If we look at the tangent function, you've done a little trig review. Tangent has some vertical asymptotes, negative pi halves and pi halves, but tangent's nice if we stay away from the asymptotes. So the tangent function also would allow substitution for a limit as long as you're not landing on an asymptote. Okay, so I do want you to have a good sense about substitution.